Road crashes and the damage they entail represent a serious issue and are one of the main causes of death. Some statistics have shown that the majority of road accidents are due to human error, and 60% of these accidents could have been avoided if the driver had been warned at least half a second beforehand. In this context, vehicular ad hoc networks, known as VANETs, are deployed to reduce the risk of road accidents as well as to improve passenger comfort by allowing vehicles to exchange different kinds of data. VANETs, which are made up of mobile nodes, can be considered as a special case of mobile networks MANETs. They are both characterized by the movement and self-organization of the nodes, but they also differ in some ways, such as network infrastructure components and a highly dynamic topology. VANET is used to improve road security and traffic management conditions and to provide onboard infotainment, such as internet access, the location of free parking places, video streaming sharing, etc. The safety-related applications represent the main objective of intervehicular communications. When an accident is detected, a vehicle can continuously broadcast information about this critical situation to the approaching vehicles. When a vehicle brakes suddenly, it broadcasts information about its current status, which is used by the surrounding vehicles to quickly detect the sudden braking. Since safety applications in VANETs have stringent QoS requirements, an efficient medium access control protocol, or MAC protocol, that can provide a broadcast service with bounded access delays and minimum transmission collision is required. Recently, MAC protocols, notably those that are based on the TDMA technique, have been used to enable multiple vehicles to use the same frequency channel without interfering with other vehicles' transmissions. The TDMA principle consists in allocating the bandwidth to the vehicles by dividing the time into different frames, and each frame is divided into several time slots. Each vehicle can access the channel during its dedicated time slot to send data messages. However, many issues arise due to the high vehicle mobility in VANETs, which can affect the performance of these protocols. Therefore, the scheduling mechanisms in TDMA-based MAC protocols should take into consideration the mobility features of VANETs. When a distributed scheme is used to allocate a time slot, two types of collision can occur: access collision between vehicles trying to access the same available time slots, and a merging collision between vehicles using the same time slots. An access collision problem occurs when two or more vehicles within the same two-hop neighborhood set attempt to access the same available time slot. On the other hand, merging collisions occur when two vehicles in different two-hop sets accessing the same time slot become members of the same two-hop set due to changes in their position. When vehicle B in the first two-hop set moves in the opposite direction to vehicle D, the second two-hop set is using the same time slot as B. Since B and D become members of the same two-hop set at instant t plus k, a collision occurs at vehicle C. In order to improve TDMA efficiency in VANET, we have proposed a distributed TDMA-based MAC protocol called DTMAC. In DTMAC, the road is dissected into n small fixed areas denoted by xi to xn of length equal to r, where r is the communication range of the vehicles. Area IDs can be easily derived using maps and GPS devices. The time slots in each TDMA frame are partitioned into three sets: S0, S1 and S2, associated with vehicles in three contiguous areas. Each frame consists of a constant number of time slots of fixed time duration. The TDMA scheduling mechanism of the DTMAC protocol uses the vehicle location and slot reuse concept to ensure that vehicles in adjacent areas have collision-free schedules, in which the 3 subsets of time slots will be reused between neighboring areas in such a way that no vehicles in different adjacent areas can access the channel at the same time, and thus no interference can occur. When an active vehicle needs to acquire a time slot, it starts listening to the channel during the set of time slots reserved for the area in which it is traveling. At the end of the frame, the vehicle can determine the set of available time slots, and then it selects one available time slot at random. In order to ensure channel access continuity, each vehicle should determine the expected available time slots on the set of time slots associated with the next area before leaving the area in which it is currently traveling. In our work, we have used VANET MobiSim to generate the mobility pattern of vehicles. We consider a VANET in a two-way highway scenario of size 2,000 meters times 20 meters, where vehicles are moving along the highway in opposite directions. We simulate, through NS 2.34, different traffic conditions by varying the speed deviation and the vehicle's density. We have compared DTMAC with VEMAC protocol, which is a well-known TDMA-based MAC protocol proposed for VANET. This figure shows the rate of merging collisions for DTMAC and VEMAC protocol when varying the vehicle density. DTMAC prevents more merging collisions than VEMAC, even for a high density, since it assigns disjoint sets of time slots to vehicles moving in adjacent areas. However, in VEMAC, the vehicles that cannot access a time slot from the set of slots reserved for its direction will attempt to access any available time slot reserved for vehicles moving in the opposite direction. This figure shows the access collision rates of the two TDMA-based MAC protocols. As shown in this figure, DTMAC achieves a considerably smaller rate of access collisions than VEMAC, especially for high vehicle densities. These results can be explained by the fact that VEMAC has achieved a higher rate of merging collision compared to DTMAC. Indeed, upon detection of merging collisions, the nodes in collision should release their time slots and request new ones, which can reproduce access collisions. Designing an efficient TDMA-based MAC protocol is an important issue in VANETs due to the rapid changes in network topology and the lack of infrastructure. In this work, we have proposed a completely distributed and infrastructure-free TDMA scheduling scheme. Using simulations, we prove that DTMAC provides an efficient and reliable broadcast service which can be used to reduce the number of accidents in the road and enhance driver and passenger safety.